My name is Martin Sapp. I'm a PhD student in the Paul G. Allen School for Computer Science and Engineering, and I'm in the Natural Language Processing group. Currently, I'm working on creating deep learning models that can leverage social common sense information, specifically through the lens of actions that happen in text, because I'm interested in bridging the gap between computer science and people and understanding their behaviors, and I think that language is a good way to get at that. I chose UW because I knew that I could do cutting-edge research here, and people were very supportive of each other.
My name is Lee Organic. I'm a PhD student in the Molecular Information Systems Lab. I work on the DNA data storage project, which means that we're storing digital information in DNA. This research is really important at this time because we're making more digital information than we've ever made before. What now takes warehouses to store, you can store it in about the size of a sugar cube. You can just throw it in a little test tube and forget about it for hundreds of years, and it'll still be there when you need it. So basically how this works is we're taking digital DNA and we're translating that into A's, T's, C's, and G's, which make up DNA. So we're using DNA to do things that computers have traditionally done.
I'm Justin Chan, and I'm a PhD student here at the Networks and Mobile Systems Lab at the Allen School. I really like that I can apply computing to healthcare because it means I can deliver a real societal impact with my research. So ear infections are the single biggest reason for pediatric healthcare visits today. What we present is an accessible and accurate approach for detecting middle ear fluid just using a smartphone and a small paper funnel. I was really attracted to the collaborative research culture here at the Allen School. We've been able to deploy our research prototypes in real clinical settings and see firsthand the positive benefits of our research.
I'm Kira Goldner. I'm a PhD student and I work in the theory group. My background was in mathematics, and so when I found theoretical computer science and I found it to be more applicable, especially mechanism design where the problems you're solving can actually really have an impact, such as low-income housing allocation or health insurance or economic inequality. It was very clear from visiting UW-CSE that here they contained a group of diverse computer scientists who are all really happy doing the work they do. And this is where I wanted to do my work.
I am DJ, a computer science student at the University of Washington. I work in human-computer interaction. This project, the hometown, is inspired by my own personal experience as someone who is hard of hearing, contains a series of IoT displays deployed in different locations in the home. And these tablets sense the information, provide that feedback in terms of the specific sound through the smartwatch. So I chose the Parallel School because of my advisors. It was a great opportunity for me to collaborate with them on projects that are important to me, which is accessibility for people who are deaf and hard of hearing.
My name is Chandrakana Nandi, and I'm a fifth-year graduate student in the Programming Languages and Software Engineering Lab in the Allen School. I have built a tool called Reincarnate. I use programming languages and compiler techniques to make desktop manufacturing devices like 3D printers more reliable and easier to use by end users. I think that making fabrication more accessible and usable can have huge impact in our society. My name is Chandrakana Nandi, and I'm CSE.
And I am CSE.
I am CSE.
And I am CSE.
And I am CSE.
My name is Martin Sapp, and I am CSE.